All right. Let's see what we got here.
All right. So,
The symbol for the true population proportion is
P.
what?
P. I think it's P, isn't it?
Oh, I thought you said B. I was like, I'm pretty sure it's not B.
No, I think the true population is P.
Yeah. So let's.
Okay. Requirement for constructing a confidence interval is satisfied. So there's two things. What two formulas have to be more than 10, right?
Yeah. 10
And,
or above. And so it's true because 0.1 times 100 is 10, and 0.9 times 100 is 90.
okay, perfect. And then I didn't understand conducting a hypothesis test.
I think it's the same thing.
Is it?
Let me look.
I couldn't find it, and I was like, "What? What's the difference between a confidence interval and a?"
Yeah, because on the prep assignment, it asked that same thing twice, pretty much.
Okay.
Because there's number.
Number.
Number 6 and number 3. Like number
Okay.
3, what's the requirements for the which is the thing we just did for the confidence interval, and then number 6 said what's the requirements for the hypothesis, and they were the same thing.
Okay. Okay. Find P tittle, the point estimator of the proportion of first degree murder.
So P is 45 divided by 60.
So P, okay, so equals 45 divided by 60, and that's P tittle, right? The P hat.
Yeah.
Okay.
So I got
0.5. 0.75. Is that it?
Yeah.
Okay, and then 95% confidence interval 1.96, and the sample size is 60. Do you do the square root of the sample size, or is it just sample size?
You take the square root of, let's see here. You take P hat minus the Z times the square root of P hat times 1 minus P hat over N.
So N is 60 though, right?
Yeah.
Okay. Equals. Do you have to on the P on N? Do you have to add N? Add something to N?
No.
Okay.
95%, so 1.96.
What did you get?
0.64 and 0.86.
Okay, so your P hat is 0.75, your
Mm-hmm.
critical value is 1.96, and your sample size is 60, right?
Yeah.
Okay, so then you do 0.75 times 1 minus 0.75
Yeah, so times 0.25.
times 0.25, okay, divided by N.
So yeah, 60.
Okay, and then you square root that?
Yeah.
That's what I wasn't doing. I'm sorry, I got 0.066, 0.06, 6.0559. I don't.
For the square root?
Yeah. 0.056.
0.056, and then you multiply that by 1.96,
Okay.
and you add that
So,
to 7.5.
boom. Who got that? Hey, how cold is it up there in Rexburg?
Freezing. It snowed yesterday,
I hate snow.
right? Freaking! I thought I was done with it.
For sure.
You're
If
excited.
you increase the sample size to 80,
What do you expect to happen to the width?
it gets wider, right?
I think so.
No, it gets smaller.
No, it should get smaller, yeah.
Smaller. Okay. Ah. Took the hypothesis for one proportion requires. Okay.
What's the smallest n can be? So that's 0.5. So it'd be 20. Um, well, because like in the last assignment we did, it said P
Right.
equals P hat,
Oh yeah, yeah.
and so you just do 0.5, and we have to have it equal 10. So half
Divided
of
by.
20 is 10.
Okay, so the next one you do equals 100, right?
Yeah.
Okay. Okay, the conditions.
So yes, they're true.
Okay, that's what I got here. Yes.
475.
Okay. 0.475. A statistic. So we're doing a critical value of 95, so 1.96. How do you convert? So P equals P hat, right? So you would type that into the output.
Huh?
On finding the test statistic,
So that's where we have to do the you take your P, which is 0.6, so your P hat minus your P divided by your population.
okay, square root.
Is there a square? I can't remember if there's a square root. I'm looking it up. Yeah, so you take your P minus, so your P hat minus P divided by your square root of P 1 minus P over N. So that nice long formula. Which P, so 475 times.
Okay, give me that formula one more time. So it's the
So P hat minus P
P hat minus P
divided by this.
divided by N.
So it's P hat minus P divided by the square root of P times 1 minus P divided by N.
P times 1 minus P divided by N. Well, that is a quite a.
Oh, excuse me.
Okay, did you get? I got negative 19.63.
I definitely did not get that.
Oh no.
I got where is it?
So,
I got negative 2.239. So you should have on top, you should have,
I just changed it, and I got negative 2.28.
I got negative 2.239.
I wonder how. Okay, so you did 0.475 minus 0.6.
Uh-huh.
Then you did 0.6 times 1 minus 0.6
Oh,
divided by 8.
I did that wrong. Okay. 0.6 times 0.4 divided by 80 square
And then
root.
that's the square root.
Copy. And so 0.475 minus 0.6 equals divided by paste. Okay. Negative 2.282.
Perfect. Okay, and then you plug that into the applet, right?
Yeah. That'll give us the p-value. So our z is negative 2.282.
And we keep both sides, correct?
On this
No,
one, it's going to be the,
less.
yeah, so right side or left side.
Okay.
Yeah, left side of it. So half of whatever it says.
I got 0.0112. 0.011.
2.
Yeah, so put 0.011. And I would reject the null.
Yeah.
Okay, perfect. Which of the following best summarizes the conclusion of this test?
So there is sufficient evidence to conclude that the water quality in the area has decreased.
Yeah, good work.
Yeah, man.
Okay, and then do you want to go over a little bit the
Yeah.
design this?
Yeah, we better do that. So we have to.
Okay.
Please write below which group members will be the main writers for each step of the project.
Can we just put bold? Is
So it's like pretty much we'll just put our names for every other part.
okay? Oh yeah, because you have to do. Okay, so how about we do it this way? Because we both have to do collect the data.
Uh-huh.
Yeah, whatever. If you want, if you want me to, because it looks like 1, 2, 3, 4. Yeah, each of us will take like 2 or 3 of them.
Yeah. Um,
Okay.
the first, third, and fifth one. Not that big of a deal.
Oh. You want me to do those ones, the first, third, and fifth?
I'll take the first, third, and fifth.
Okay.
So
I'll take make interference and the presentation.
So the first one is design the study. The third one is make interference. So you'll take describe the data and take action.
Oh, okay.
Yeah. So I'll make the presentation.
Okay. So just to clarify, first step one, design the study. We both do step two. Describe the data. I do that.
Uh-huh.
Make interference. You take action. Me. PowerPoint. You.
Yeah.
I'll help you with others. Yeah. I don't think it'll be that big of a deal. Okay, and then we decided on M&Ms.
Yup. Our research question is, are the distribution of colors between plain and peanut M&Ms equal? So the population is four. Do we say 4 or 6 bags of M&Ms?
I think we'll each do 4, so 8 bags total.
Okay.
We'll each get 2 plain and 2 M&M. How does that sound?
Yeah, that sounds good.
So 4 bags. Okay. Null and alternative hypothesis.
So our null is going to be that H O. So the null is going to be that plain equals peanut. And our alternative is that does not equal peanut. I don't even know how to do a cross down equal sign. Oh well.
There.
That's not.
Now, are we going to do like... So our null is saying that all of the colors in a bag of plain M&Ms equal the same amount of colors in the peanut M&M?
Yeah.
Okay.
So like there's going to be 20 blues and 20 in each of them. There's going to be 30 reds in each of them, something like that.
Oh, okay.
Plain equals peanut, and then the alternative is that they don't equal.
Okay.
So then to design the study, which sampling method will your group use? Yeah, let's see. It's pretty much systematic. I mean, we're just picking random bags of M&Ms. So it's a simple random sample or it's a stratified sample. So a stratified sample says subjects are in groups according to similarity of some characteristic. And then there's an SRS of each group. I think it's just a simple random sample because, I mean, the bags and the M&Ms in it are random.
Right.
So I'm pretty
I
sure
agree.
doing this is simple random sample.
Okay, then.
Describe in specific detail how your group will collect data using sampling methods stated in question 4. Also, what sample sizes are you planning to obtain per population? So we will have 4 bags peanut, 4 bags. So then the colors will be
I don't know if we want to get this specific, so um, says so each bag typically contains between like 30 to 38 pieces of candy.
okay. So it was between 30 and 38.
So it says 30 to 35 for a 1.5 ounce bag, but a typical bag is 1.74.
Okay.
So I would say between like 30 and anywhere from like 30 to 40, or you could just, I don't know, put
So I put
33 to
38. It's not a big deal.
perfect.
Each bag contains on average 30 to 38 M&Ms. Then the color. Okay. Counted to compare. So I put all the colors will be separated and counted to compare the plain quantity to the peanut quantity by color. And then an armed random bags.
Perfect.
Okay, why do you think the sampling method? Oh, that's what. I don't think I have to describe that. Okay. Why do you think this sampling method described in the questions in steps 4 and 5 will give an accurate representation of your population? This
Um, I don't know that. I don't know why it wouldn't. I don't. I understand it's just a simple random sample, but
and I mean we're going to have well over we'll have about just over 100 M&Ms.
that's a pretty good sample size.
Yeah. So I'm just going to put the sampling method will give an accurate representation because the population is high enough for a normal distribution.
I like that.
And that it's under the central limit theorem. Each group member sign below that you will not collect data until your project has been approved. Okay.
What? Yeah, if you want to just like type my name right there, I don't know.
Just type your name in.
So do only one of us submit that?
I have no idea. Let me see what it says. It just says put your project names, so the group member names, and then saying that we won't do anything below it. And then the instructor has to sign off on it. I wish he had like an example of what this is supposed to look like. I knew if like
Yeah.
these needed to be paragraphs or sentences.
I
Oh well, I just put it as sentences because I don't know how else to. Because I mean, all the studies that
Yeah.
we've seen on the examples, they're all one little paragraph, which all of this would make. So,
Yeah.
all right, cool. So, file, save as.
Will you send that to me too?
As a link in the comment board right next to the thing we're on. I should be able to do that. Let me see. Attach a document. Yeah, I'll just have to email it to you. What's your email?
Tyler J Moser
Tyler
20
J. Moser.
20 at gmail.com.
Alright, send that real quick. Compose, trust, compose. Come on. Alright, it says it was sent.
Cool.
Um,
Got it.
State the population, state normal state, describe specific details, state with overall sample, overall organization. And neatness of the document. Yep, that sounds about right.
Do you just want to read it over real quick before I submit it?
I think it looks great. I opened it right here.
Okay, cool.
I think it looks great.
Then I shall submit. Choose. Submit. Yes.
Okay, man.
All right, man. Sounds good. Enjoy the Dodgers, eh?
Freak, yeah.
I'm kind of jealous.
Are you a baseball fan?
I don't really watch it, but I played it growing up. So, I mean, it's fun to watch on occasion.
Games get really long.